Saxon Calculus Lesson 26 is about the locus development implying here of an ellipse. They just didn't say that in the title, and also equation of the ellipse and then foci points. So part A, locus development, they want to basically remind us that an ellipse is a squished circle and that it has two focus points in it. And if you remember from trig, you are extending a string between those two focus points, holding with your pencil or pen and rotating around so that when you get here, this is like the shortest distance for the string, and then it's going to get a little wider here for the other parts of the ellipse. Now, my drawing doesn't necessarily look that way, but that in general is how you're creating an ellipse, and it's got the two focus points. So the box on page 140 at the very beginning of the lesson says, an ellipse is the locus, equidistant, of all points in a plane such that the sum of the distances from any of these two fixed points called the foci is a constant. So their wordy version of basically what I told you with the stretching of the string. All right, and then they remind you on the top of page 141 that the equation for an ellipse is x squared with a number underneath it, y squared with a number underneath it. And this has to do with the length of the full distance across. And then when you take half of that and square it, that's where you're getting these numbers that are underneath. There's a plus sign in between them. And the only way you know which one is the major axis and which one is the minor is based on which number is bigger. And then the whole entire problem equals 1. Now in part B, they do the equation of an ellipse. And so, they just use the terms I just used, major axis and minor axis. Whichever one is longer, whichever one is shorter, then is the minor. Let's see. Oh, they're saying the value of the a, which would be technically under the x squared, is always written first. So if this were the larger of the numbers, it's saying it would be like y squared over a and then x squared over the b. That's not really critical. You're just focused on getting the numbers underneath the x squared and the y squared and making the problem equal to 1. Now, let's look at example 1. Graph, and they give us 9x squared plus 25y squared equals 225. So this formula is not in the correct format for us to graph. So we need to divide everything by 225 and simplify it. So we get x squared over, and 9 reducing with 225 is 25 plus y squared, and then 25 over 225 is reducing to 9, and of course we know it equals 1. So now when we graph our ellipse, there's no numbers attached with the x and the y, so my center is still at 0, 0 for this case. If this were in parentheses squared, then we know we shifted with the center. So we square root the 25 and get 5. So on the x-axis, I'm going 5 both directions. So the major axis is a length of 10, so I'm going to label that 5 and negative 5. And then the square root of 9 is 3, so on the y-line we're going to go 3 both directions, and that's going to be the ellipse connecting all of those, not vertice points, but edge pieces. Now, minor axis I would call 6 then. And they didn't ask for any other information, just the graph. Example 2, write the equation of the ellipse whose center is, well, this one has changed. The center is 7, negative 3. The major axis is vertical, so that's up and down is the major, and 8 units long. And the minor axis means the horizontal one is 3 units long. So write the equation of it. All right, so we're going to begin with x, and when I pull this number from the parenthesis, I know I'm sticking it back in a parenthesis, but we're still following the rule, change the sign, squared, plus y plus 3 squared, and we know it's going to equal 1. So then half of the major axis is 4, and this is going to be under the y one because that was the major. So there's, yeah, don't worry about that. We're just going to write it this way. Half of that is 4. 4 squares to 16, so that's the denominator. And then this one, half of it is 3/2, and so I'm squaring 3/2, which is going to be 9/4 written underneath. Write the equation of it. Oh, just the equation. I don't have to graph it. That's all we need. Then, now when they wrote theirs, I see that they left them with squareds, like 3/2 squared and 4 squared. I'm so used to solving them out. Either way is going to be acceptable. Example 3. Describe the ellipse whose equation is 3x squared, 2y squared, 6x, 8y plus 5 equals 0. Well, that certainly is not in the correct format. So to do that, I know I need to move the 5 over, so it's -5. And I'm going to have to complete the square because I have an x squared and an x term, and I need it in this format. So we're going to pull the 3 out, leaving x squared. And when I pulled 3 out of -6, -2x plus, and I have a 2 in front of the y squared, so 2 is pulling out and leaving me y squared. When 2 pulls out of that, it's 4y. Now to complete the square steps. So 3x, and now my parenthesis is going to be squared. So half of -2 is -1. So remember the steps for completing the square. Half it, square it, add it to the other side. So -1 squared to 1 times 3 is 3. Add 3 over here. Plus 2, repeat those steps, y. So half of 4 is 2, 2 squared is 4, 4 times 2 is 8, add 8 to the other side. So the whole problem equals 6. And then I need it to equal 1, so I'm going to divide every part by 6. So I have x minus 1 squared, and then 3 divided by 6 is 2. And y plus 2 squared, 2 divided by 6 is 3, and the whole problem equals 1. I'm looking for that answer. Yes, okay, they have it in the square rooted format. This format is still perfectly acceptable. Now, do they want me to graph it? Describe it. Okay, so its center will be at +1, -2, because we change it when we pull it out. Now, the major and the minor are a little trickier because you're going to have to square root the 2 and double it. So that's going to 2 root 2's, and this one's going to 2 root 3's. So I'm fairly certain that root 3 is going to be larger, but I want to do that on the calculator just to see what decimal it actually comes up. And so it is this one that is larger when you do that. So the major axis is the 2 root 3. That should be the full length. Yes. Major is 2 root 3 and the minor is 2 root 2. Did they give me any dimensions? No. So I think I would actually say, if it were me, units perhaps with these, just kind of as a label, but they don't have it, so it seems to be all right. And let's see, is there anything else they want here? No. Part C then goes to the foci points. And let's jump to example 4. Write the standard form of an equation of an ellipse whose vertices are at, vertices are at 0, positive and -6, and foci are at 0, positive and -5. Okay, so when I graph 0, positive and -6, so 1, 2, 3, 4, 5, 6 up is the outer edge, 1, 2, 3, 4, 5, 6 is the minor, and because the foci points are landing at the 5 focus and the -5, also labeling a focus point. Because of that, I know that the major axis will be the y-axis because the foci points always land on the major one. Then I connect from the focus point down to an unknown spot here on the x-axis. I always want to create a right triangle. And then I know that that length up to the focus point is 5, because that's what we counted, and the hypotenuse, if you've forgotten from before, always matches the full outer length of the vertice. Then Pythagorean theorem will find you the x number so that you can then put it in the equation. So 36 minus 25 is 11, so this is the square root of 11. So let's see, write the standard form of the equation. All right, so we need x squared, and the center was at 0, 0. So x squared over and y squared over, and it equals 1. So the x number is square root of 11, but we're going to square that when we write it in the problem, so that goes to 11. And then 6 is the outer, so when you square that, you get 36. And it equals 1. That is the standard equation they're looking for. That's all they wanted. All right, example 5. Write the standard form of the equation of a horizontal ellipse. All right, horizontal's this way, so the major is the x-axis, whose center is at origin. All right, so 0, 0 for sure. The length of the major is 10, so this one is 10, and the length of the minor, so going up and down, is 4. And they're looking for the coordinates of the foci. But they want it written in standard form first. Okay, so we know we're going to have an x squared with a number, a y squared with a number. It's going to equal 1. That's our standard equation, start 4. Center was 0, 0, so no numbers are attached with these. Since this one is horizontal, and that's the x-axis, we take half of it, that's 5, and 5 squares to 25. And then the minor one, we take half is 2, 2 squares back to 4. So that should be the standard equation. Now, to get the foci point, 1, 2, 3, 4, 5 on both sides. 1, 2, 3, 4, 5. And then I don't need to do the other one for preciseness, although we know that it's 2. And -2. I'm going to connect randomly to some point because we don't know where the foci point is, but I am going to connect it then to the 2 since we know what that is. So I know that this one's 2. This one is the unknown that we're looking for, and the hypotenuse has to match the 5 that we have for sure. So we are working on the Pythagorean theorem here. So we have 25 minus 4 equals 21. So this is going to be the square root of 21. And I can get a decimal from that. But since I don't have to actually graph it, all I need is to list the vertex point, the focus points, sorry, not the vertex points. So I know I'm going over to the root 21, and I'm doing that because it wants the other side as well. So it's positive and negative root 21, and then I'm not moving up or down from there. So that becomes my focus points. And that was the other part that they asked for.